Assalamualaikum warahmatullahi wabarakatuh. Hello, ladies and gentlemen. My name is Ali Rahmat. I am from the Research Center for Limnology and Water Research, National Research and Innovation Agency, or Badan Research dan Inovasi Nasional. Today, I want to present our research with the title Chemical Characterization of the Biochar from the Lablab Beans under Low-Temperature Pyrolysis. Introduction. Lablab purpureus, or in here we can also call Lablab beans, is a native plant from the African tropical and subtropical regions. So we can see the picture. Actually, there are some color like the white, purple, and red. Lablab bean is now growing all over the world for the variety of the purpose. In the Africa, they use as a vegetable in West Africa, Ethiopia, and Malawi, where the young green of food, pods, and immature seed are eaten boiled, and the fruits in the northern Nigeria, Kenya, and Ethiopia. In India, also I think in Indonesia, the seeds are primarily used for the food and are processed into protein concentrate similar to soybean. However, in agriculture industry activities, one of the problems that arise is the product was expired or other damage. This can be happen in the Laplapian farmer where the stored beans exceeds the storage time, so the beans cannot be used. The bean cannot be used as a seed or the process into the feed because they have the experience as a significant decrease in the quality or pest attack that most damage in the most of the beans in the storage area. So we can see in the picture maybe some pest attack, they will decrease the quality and the beans cannot be used. After that will be waste. So if this waste cannot be used for food for the animal, so we need to destroy or maybe be burning, so we can modify it or convert the waste of the bean to be biochar. What is biochar? Biochar is charcoal resulting from the heating of the biomass in the oxygen-limited environment. In this picture, we can see the several types of the biochar from the different type of the source of the biomass. So why and what is biochar? Biochar is the 2000 years old practice that converts the agricultural waste into a soil enhancer that can hold the carbons, increasing food security and discourage deforestation. Biochar can be the important tools to increase the food security, cropland diversity in the area with the several depleted soil, scarce organic resource, and inadequate water and chemical fertilizer supplies. Also, biochar is the powerful, simple tool to combat climate change. So, biochar can contribute as following like enhance productivity for farmland, achieve the environmental friendly agriculture like organic agriculture, sustainable carbon sequestration, rural promotion through the Carbon Minus project, and environmental friendly education. Converting the Lablab waste into biochar is one of the opportunities to manage waste. The result of the biochar can be used to improve the soil condition in the degraded land or degraded soil. However, to choose Lablab as the biochar must be evaluated by the chemical content. Whether it is suitable or not due to the criteria for the good biochar is the contained lot of nutrients. The quality of biochar depends on the raw material and the production process. In this case, the difference of the temperature of the pyrolysis is a treatment. This research aims to investigate the chemical characterization of the Lablab waste-derived biochar under different pyrolysis temperatures. The method is the raw material, and then we furnace for 4 hours in the temperature 245 degrees Celsius and 345 degrees Celsius. After that, the charge we ground it and sieve it in 255 micrometer. After that, will be analyzed using the X-ray fluorescence. So the results, the approximate analysis of biochar under different temperature, we can see the yield in the 255 degrees Celsius produce more biochar compared to 350 degrees Celsius. We can see the biochar is the producing from the heating where the uh, raw material like cellulose, hemicellulose, or lignin is contributed in the yield. So the loss of the yield in this study could be attributed to the destruction of the lignin cellulose structure and the combusting of the organic material at the high temperature of the pyrolysis. So in the high biochar yield in the low temperature indicated that the material were only partially pyrolysis. And next is the chemical properties of the biochar under different temperature after burning. We can see in this table, I think only two the main uh, element in this biochar. First is the kalium or potassium with 75 until 76%, and phosphor with the 16% until 70%. And then there are magnesium, sulfur, and others. In this case, the increasing the temperature also increasing the concentration of the element. However, the increasing is not quite high. This is a little ambiguous. This cannot be counted if the temperature strongly influence the uh, chemical content of this biochar. Uh, in this dominant compound is the almost the alkali. We can see the kalium, potassium, and magnesium, where the nutrient also is we compare to the standard of S&E for the compost is quite higher than the standard, and the existence of the kalium positive or magnesium positive of the biochar can, if we apply in the acid soil, the alkaline cation from the biochar will displace the acid soil exchangeable H plus or Al3 plus ion, the rising soil pH and improving the soil fertility, especially in the acid soil containing with the high level of toxic element aluminum, and in future we hope it can increase the crop productivity. The conclusion is the biochar where a biochar yield were 40.2% and 30.22% at the pyrolysis in 250% degrees Celsius and 350 degrees Celsius of the pyrolysis. And the the dominant content is the kalium, phosphor, and magnesium, where in the future potassium and phosphorus with a high concentration can be used as the candidate for the soil amendment due to the high micronutrient. I think that's all. Thank you very much.